We're going to finish this week looking at how circles and tangent lines interact on the coordinate plane. So we're going to graph circles and lines, and those lines should be tangents. The first example here says, find and graph the equation of the tangent to this circle, x plus 1 squared plus y minus 2 squared equals 13. At this point, negative 3 comma negative 1. So remember, I got to find the center of that circle. That's at, well, that'd be negative 1, because that's x minus negative 1, comma 2, y minus 2. So I'll go to negative 1, 2. That's the center. It also gives me the point of tangency, which is negative 3, negative 1. And so the real question is that on the circumference of this circle? Is the radius here should be the square root of 13. Well, if I go over 2 and down 3, let's think here, 2 and 3, that's 4 plus 9, that's 13. So the radius is the square root of 13, so that works. So that means I could use, groups of 2 and 3 to find all kinds of different points. Like if I go over 3 and down 2, if I go over 3 and up 2, or if I go over 2 and up 3, go over 2 and up 3, kind of like I can just find a bunch of different points that are on the circle like this, and now I can kind of make an approximation of what the circle is going to look like we practiced in the last video. So that's good enough. Okay, now I've graphed the circle, and that point is right there on the circumference of the circle, but I'm supposed to find the tangent line. Well, that radius, remember, and the tangent line have a special relationship. They're perpendicular. So I want to make a line that's perpendicular to the radius. So that means I got to think about slope. Well, the slope of the tangent, of this radius rather, is up 3 over 2. And so the perpendicular slope of that would be negative 2 over 3. It's going to go down 2 and over 3. So from that point to graph it, I could just, because I know it's going to go there, I'll go down 2 over 3, down 2 over 3. Or I could go up 2, back 3. And then I'll just carefully connect those points, and look what I get. Voila, I get a tangent line. I haven't actually given the equation of the line yet. Well, let's just say it's negative 2/3 times, I'm just going to use point slope form, because it goes through negative 3 comma 1. So that would be x plus 3 minus 1. I just used the point negative 3, negative 1, and I wrote the equation in point slope form. So now, example 2 says, find the equation of any circle tangent to the line y equals negative 3x plus 4. Let me just graph y equals negative 3x plus 4 real fast here. And then it doesn't specify which circle, so I just need to know that this is the tangent to the circle. So I'm going to pick a point, because this seems easy, and I'm going to figure out where the center of a circle might be. And just like we saw before, the tangent line has to be perpendicular. Negative 3, the perpendicular slope to negative 3 would be positive 1/3. So if I go up 1 and over 3, then I should be able to find points that might work. In fact, I'll just use this point here as my tangent line, or the center of my circle rather, to this line here. And then I could go up 1 and over 3 in lots of directions, use 1 and 3 to find different points that are on the edge of the circle. Like this, down 3 and over 1, down 3 and over 1. So like that, I've kind of graphed the circle, and it is tangent. You can see that it's tangent. And so the equation of that circle, the very last thing would be, well, the center is at 4 comma 2, and the radius is over 3, so 3 squared plus 1 squared, that's 10. So the equation would be, let's think here, it would be x minus 4 squared plus y minus 2 squared equals 10, because that's the square root of 10 squared. Have fun with the practice problems.